Hi, everybody. Professor Sackett-Taylor here. This video lecture is going to cover content from Chapter 9, Ecological Economics Basic Concepts, for my course I'm teaching, Econ 321, Natural Resource Economics. In this chapter, we're really looking at ecological economics as a new subdiscipline of economics that differs in quite a lot of ways from the traditional theoretical approaches. Ecological economics is a perspective that we take on looking at problems that exist at the intersection of ecological systems and economic systems. So it really requires that we take a macro level perspective, a big picture perspective. Ecological economists believe that we need to use an approach called methodological pluralism. This is the view that we can have a way more comprehensive understanding of a system and the problems associated with that system if we use a combination of different perspectives and include people in the conversation who have different areas of expertise. So one of the things that this means is that as an ecological economist, you can't rely solely on the discipline of economics to inform your understanding of a system. We have to tap into the wisdom that comes from scientific, biological systems, chemical systems, physical systems. So what this requires is that we're taking an ecosystems lens. We're looking at the environment as this very complex system of interactions between each of its component parts. And so the focus here for an ecological economist is in the value of natural capital. That is the value of the resources provided by the environment beyond just their production value. Traditional economics looks at inputs primarily through two categories. That's labor and capital. Once in a while in the circular flow diagram, for example, you'll see a third category of input, which is called land, but it's never given much emphasis in any of our economic models. And this land variable encompasses everything that was given to us from the earth, all the complex ecosystems and subsystems and subsystems found within them. So as an ecological economist, we hold a fundamental belief that we must insist on seeing the human economy as being a subsystem embedded within the Earth's biochemical larger system, and that we have to therefore obey the laws, the rules, the purpose and function of that system in order to perpetuate our own survival. So hopefully you've had an opportunity to watch this TED Talk. We're not going to play it here during this lecture, but I would like you to view this separately. It's about 16 minutes long. It's an excellent talk given by economist Pavan Sukhdev on basically how, in terms of economic market activity, economic value, nature is often invisible in those policy discussions. He goes through a number of different examples, which I think that you'll find rather poignant and relevant, of ways in which environmental systems are not adequately valued in important decision making. So why is a focus on natural capital so important? Well, we cannot exist in an economic system without the natural system that we are embedded in. Natural capital entails all of the natural resources and ecosystems that give us the ability to produce goods and services, and that takes on the burden of holding the waste and emissions from these production practices. If we extract too much from nature, we are the direct cause of environmental damage, and we begin to degrade the availability of natural capital, and therefore we end up putting our own economy at risk. This is a concept called natural capital depreciation. You may have heard about capital depreciation in any of your business or accounting classes. Traditional economics does not consider the depreciation of natural capital when measuring economic welfare. Natural capital depreciation is this deduction in national accounting that would be taking into account the loss of natural capital. This would be a reduction in the supply of resources, such as mineral resources, timber, wild habitat, things like that. All of the functions that natural capital serves for our economy, supplying us with food, water, energy, and carbon storage. So if we are to take into account natural capital into our national accounting, we have to acknowledge that natural capital exists by different laws, like I said before, that are largely driven by the scientific realm: physics, biology, ecology, and chemistry. In terms of natural capital accounting, ecological economists have come up with several variations of this, different approaches to valuing natural capital. The first is physical accounting. This is where we use satellite imagery and then geographic information systems to actually map out the physical space and physical abundance or availability of resources. And then we can use those measurements over time to look at the variation in abundance and to measure degradation and depletion. Ecological economists also use a concept of sustainable yield, which we saw in the lecture on common property resources. Sustainable yield came up when talking about fisheries. This is this idea that we can mathematically, using the biological, physical, chemical, ecological factors, determine an ecologically sustainable level of human use of those natural resources, and that we could create policies to sustain those levels over time so that we don't cross the boundary into degeneration or depletion of that resource. Ecological economists have also dealt with the valuation of natural capital in terms of planetary absorptive capacity. This is where we look at the planet's biological systems and the specifically mostly like chemical foundations for how the environment is able to handle the excretion and the emission of waste and pollution. And we could find an acceptable level of waste that would allow the planet to absorb that waste and regenerate. So the difference here really is the difference in whether you believe that human-made capital is or is not substitutable for natural capital. Traditional economic models, Keynesian, Malthusian economics, would say that human capital is substitutable, that you could replace natural capital with manufactured things. And so therefore, the preservation of natural capital is not as important. Whereas an ecological economist would say there's really a more complementary nature, this is a more realistic model of the relationship between natural and manufactured capital, that they're used together. For example, we manufacture automobiles, and then in order to make them run, we harvest the natural resource of petroleum, gasoline. And so this is a complementary relationship between natural capital and manufactured capital. So a definition of sustainability that incorporates the value of natural capital would therefore lead us to the following statement: that countries should aim to conserve their natural capital by limiting its depletion or degradation, and instead use the economic capital that is produced within that economy to invest in the renewal of any natural capital that has been depleted. So if that's the kind of statement that's going to inform all of our policy views, what this means is that we believe there is an optimal scale. So going back to a traditional economic view, macroeconomic models tend to recognize no limit on an ability of an economy to grow. That is, there's an infinite amount of growth possible and no limit on its size or scale. And we use primarily one measure of this output and growth, which is GDP, which does not account for any natural capital depreciation. An optimal scale is a concept that says that economic systems have like an optimal size to them, beyond which any further growth actually would lead to lowering our well-being and begin to degrade and deplete the resources we have available to us. So an ecological economist would say that economic growth cannot be infinite, and therefore having a consistent, never changing goal of economic growth isn't realistic or sustainable. So taking a systems approach here would mean that we need to recognize, if we're thinking about modeling the complex world we live in, that the economic system is a smaller subsystem that is open, meaning that it exchanges resources with the system around it. Whereas the global ecosystem is a closed system. It has planetary boundaries that we experience in our own lifetime the negative effects of exceeding, right? When we, because of the planetary boundary we have, when we use up a source from the environment, or we are overusing a sink in the environment, we see the following problems: global climate change, ocean acidification, ozone depletion, freshwater pollution, land systems change, where we're converting natural spaces into industrial spaces, biodiversity loss. These are all a result of not fully acknowledging that the economic system has to live by the same planetary boundaries of the global ecosystem that contains it. This means that there is a carrying capacity to the earth and the level of population and consumption that it can sustain with the resources that we have available. Sometimes, in order to communicate this to the general public, you may have seen the concept of an ecological footprint. This is a measure that converts like all of a specific activity and the human impact from that activity into the amount of land that would be required to supply all of the necessary resources and assimilate all the wastes from that activity. You can go online and find a lot of free ecological footprint calculators. Maybe we'll do that during class and see what comes up for us. But this is a way where we can like kind of compartmentalize this very, very large problem and communicate it more effectively to a more generalist audience. So here is a graph showing the per capita ecological footprint for different countries, and then the actual available land. So remember that ecological footprint is measured in land. I think it's square hectares. So it's the amount of land that would be required to produce the resources and assimilate the waste of all the human activity. And so you could see then if we compare it to the actual amount of land, we can determine whether we are basically like living beyond our boundaries. We are living beyond the carrying capacity of the environment, which holds us, which in the United States, we are, right? You can see that that black bar is measuring our ecological footprint as a country, and the much smaller, in fact, about half as small blue bar is the truly available land to account for that human impact. And so that's where we start seeing these negative impacts: global climate change, ocean acidification, biodiversity loss, freshwater resources depletion, is because we are living beyond the carrying capacity of the earth. So this leads us to this kind of greenwashed buzzword of sustainability. What most people think of sustainability is what ecological economists would call weak sustainability. It's the view that natural and manufactured capital are substitutable. So while we want to slow the depletion of natural capital, it's not our primary concern, because there's this belief that we could just replace it with human-made capital. Strong sustainability would be a view that natural and manufactured capital are not substitutable. And so therefore, we have to preserve our natural capital levels, even if it means reducing consumption and production of human-made capital. Since we actually live mostly under a weak sustainability framework, these are the things that we see happening in our society. Private owners of natural capital fail to consider its full ecological value when deciding how to use it. Property rights for natural resources tend to be really poorly defined because they're not, bought and sold in markets. Private property owners also therefore have to operate in a short-term perspective, almost business cycle to business cycle, rather than considering long-run implications, even intergenerational implications. And that what it results in is, through our economic activity, the truly irreplaceable resources that are absolutely not substitutable by human-made capital face total depletion or extinction. If we were to integrate strong sustainability into changes to existing policies or introducing new policies, we would have to promote intergenerational equity. That is, ensuring natural resource preservation, not just for the current generation, but for future generations as well. We would have to recognize that ecological systems are the grander, larger system within which the economy is a subsystem, and that ecological system has boundaries that are irreversible. And we would have to use the precautionary principle, which states that we would preserve before use, that use or extraction is always the last choice when dealing with natural capital. So to get an idea for the value of ecosystem services and an example of all of this, how do we look at an existing problem within a system and then pose or propose a change to a policy or a new policy that addresses those issues? So we're going to watch two different videos here. And the first video is about the problem itself, how we undervalue ecosystem services.
The productivity and sustainability of agriculture, forestry and fisheries depend on healthy and biodiversity-rich ecosystems. This is critical to maintain environmental flows, nutrient-rich soils, clean water, pollination, and the control of pests and diseases.
Ecosystem services and biodiversity seems to be a word that people don't understand. And it's about our life, the life on the planet.
And people don't understand that we have to protect these environmental services in order to maintain clean water, good soil, rich biodiversity for the future.
So it's important that policymakers understand the value of the production of ecosystem services and promote and help farmers to produce much more of it, not only for themselves, but also for the millions of people who depend from agricultural systems.
You need to take a landscape as a whole, because when you have forests, you have pastures, usually you have agriculture, and all of them use these environmental services, but also help protect environmental services if the management is done in a good way. So it is an integrated approach which is needed and not a sectorial approach. And this obviously needs a lot of collaboration.
Many countries are understanding and adopting policies to protect and maintain pollinators. Pollinators give you 35% of the total food we produce. It is impossible to think to produce some crops without having pollination. And we have made calculations, and this is equal to more than $200 billion value in terms of food production.
Without ecosystem services and ecosystem management, there will be no survival, because the water will not be available anymore in the quantity needed, pollinators will disappear, and the soil will erode. So without taking care of ecosystems and their services, there is no food production in future. Very simple.
So ecosystem services is a really big idea, but essentially, just like this last slide says, it's the beneficial services provided freely by nature. And this can be broken down into 4 component parts. So the value of ecosystem services is first cultural. So the way in which we interact with the earth, the way in which the earth provides for us, we find value just in its existence, but we often tie our ethical, moral belief systems to our relationship with the earth. It also gives us culture in terms of the recreational and ecotourism value of those resources. So you can think of like certain regions are known for certain environmental places or things that you can enjoy. And this brings cultural value to that space. There's also provisioning value. So this is where like we actually use ecosystem services to produce things. So food, fiber, biomass, fuels, fresh water, natural medicines, all are things that we extract through an ecosystem, producing them as a system output. There are also ecosystem services are supportive for our production. It gives us nutrient cycling, water cycling, soil formation, photosynthesis, all the things we need to actually manufacture agricultural products. And finally, ecosystem services are regulating the entire system. It regulates air quality, the climate, our weather, water runoff, erosion, natural disasters, pollination. These are things that just keep the systems running, right? So there's so much value to ecosystem services, but how do we preserve them? How do we get other people to value them? Well, one approach that ecological economists have taken is a program for payments for ecosystem services, where you would actually pay constituents, pay people to preserve ecosystems instead of using them for their productive value. This video here is going to talk about a specific policy example and what they saw as outcomes of the initial introduction of that policy.
My name is Jennifer Alex Garcia, and I am a professor and head of the Department of Applied Economics at Oregon State University. I study a program of payments for ecosystem services. These kinds of programs are sometimes called PES programs, and the one that I study is located in Mexico. So the idea of a PES program is that you pay somebody to do something environmentally friendly. So in the case of Mexico, people are paid to conserve forest. And it's not just that they're being paid for the forest, they're also being paid for the services that that forest provides, like carbon sequestration, biodiversity conservation, natural beauty. We find that the Payments for Ecosystem Services program in Mexico reduces deforestation and supports people's livelihoods. And it's most effective where the forest is at highest threat. So if producers had the intention of actually cutting the forest down, then this program could have a big impact. In order to assess whether or not PES prevents deforestation, we use data that is based on satellite imagery. So that we measure the vegetative cover using satellites and translating that into measures of forest. And then we compare the land that's enrolled in the program with land that applied to the program but wasn't accepted. So you have a sort of treatment and control group. And by making the comparison between those two, we can measure whether or not the program actually prevented deforestation. Land use change accounts for about 11% of global carbon emissions. And preventing land use change or deforestation is one of the lowest cost ways that we have to address climate change. It's cheaper than changing polluting technology. It's cheaper than reforestation. It's basically should be the first thing that we do. Besides being low cost, it's nice to preserve forests for other reasons. So forests provide carbon sequestration, and that's a great thing, but they also provide other services like conserving biodiversity so we can extract future technologies and preventing erosion and landslides that are a big risk in a lot of places. This program also fits in well to my larger goal, which is to look at environmental policies that help conserve the environment while also preserving people's livelihoods. I think this is probably the most pressing issue that we face in the world, how to reconcile economic growth with environmental conservation. And it's something that we should all be concerned about. It's why I do all my work. I think that climate change can be a discouraging issue to think about because it's so big. Individual changes can help combat climate change. Things like walking to work and composting your food can have an impact. But the most important thing that people can do is to vote for politicians who are willing to put in place policies to reduce greenhouse gas emissions. Without big policy changes, we can't really address the problem.
So there's an example of a focused study that you could turn into a Vensim model, right? Where your primary stock is an amount of forest cover in a particular area, and you have like an outflow, which is deforestation, the use of, from cutting down those trees, and that rate of deforestation could be informed by different policy measures. For example, here, a payment to people to conserve that forest. And you could look at predicted changes to forest cover over time, the longer that this program is going, but you could also vary the level of the payment to see what the impact on forest cover would be of that. So I'm hoping that you're beginning to start to think about your system that you want to focus on in this class for your research project, and how you could hone your idea to some primary stock of interest and the inflows and outflows of that stock, the feedback loops of how the system interacts, what other maybe larger systems or smaller subsystems are contained within, and where you might be able to alter or change a variable through the introduction of an environmental policy. So lots to think about, and I'll see you in class soon so we can be thinking about your project and what policies you might propose to affect long-term change. I'll see you next time.